All right, so we're recording. So right here, I'm gonna show a project that I did in my MBA class. And basically, this project was all about data cleaning. So reading in the data, looking at what we have, and cleaning and consolidating things, and then kind of looking at the results afterwards. So the data here is actually AAA member data. As you can see, this is this is actually a pretty large file. So that's why when I go and I read in the data, it doesn't immediately tell me the shape of the data. So basically here, we have all the imports that we could have for packages, or not that we could have. I confuse. That's definitely an exaggeration. And then we have the data file, which actually here the data file is in the same directory as the project itself. So that's why this path is just the data name itself with the extension type. It usually it's a much longer path or a relative path or more complicated than that. So here we go. We read in the data. We can get the raw shape of it. So we read in that data such that the delimiter was the pipe, because when we looked at the data, there was a lot of pipes in there. And right now, it's not really in the best shape because, as you can see, we have 217 lines of, or I'm sorry, rows in the data, but it's one column. So that's not something that's pretty ideal. And that's because when we just read in the data, that's the way the computer reads it in base. So what we want to do is we actually want to convert it to a data frame, which is the Python pandas object and class that we use for a lot of data manipulation and stuff like that, which is going to be really, because it's going to come in handy. And then we define some basic utility functions. So I'm just going to step through this. This is just to basically you pass in a data frame and it prints out a blurb whether or not how many rows you have and how many columns you have. Basically, this was just to show that as we made changes over time, how our data was changing. So and this right here is to just keep track of our initial data dimensions. So the first part was column cleaning number 1. The idea to this was just combining different columns together. So what we wanted to do is we wanted to look at the data and see what we felt could be consolidated into a different data frame or a different column of the data. So here we looked at data across profits for years 1, 2, and 3, and we felt, it's great, but it might be more useful to have like a running average, because even like in some of these values, 2 years in a row they had like the same profits. Maybe that's because of contract reasons, or really probably because AAA is like an ongoing membership. So we felt that having an ongoing average would be useful. And I'm just gonna step through here. We actually created a new column in the data frame that was that value on average. Or actually, I'm sorry. This is just a test to see if we can do it. Down here is calculating the average. And what we did is we actually filled in any null values with a 0 so that they would not sway the value. They would not sway the average as we went. We did the same thing with like member dues because we felt that it would make a lot of sense to total the member dues together. So we did the same thing where we made a member dues column. And then member cost total, we kind of did that because we thought that would be useful. And then we kind of did similar stuff and to try to figure out the age at time of enrollment. And what was interesting is we didn't have some data. We had like age and then the member of tenure years, but we didn't know like when they had joined AAA or some of the stuff that we took our own like creative liberties and wanted to know about. So once we did this, we wanted to look at the columns that were extremely similar in their naming convention, like ERS ENT count year 1 and ERS ENT count year 2, and we wanted to try to get rid of that because that makes it a lot less human readable and is more likely to cause mistakes. So this right here, some of the commented out stuff was actually just us testing different things. And then these were the things that we were told to change. So member dues for years 1, 2, and 3, member cost per years 1, 2, and 3, age and tenure of columns, which we actually just spoke about. But basically right here, you can see when I run this, I'm running it through as I step through this notebook. The number of columns before we deleted stuff was 111, and we went through and we deleted the similar convention, because what in the first part we had actually taken these and made a new column, such as the average profit value or the total of member dues or the total cost per year. And since we had already made a column that kind of captured this data, we just deleted them, which you can see running the helper function that we designed above. There's less columns after cleaning it. So if we keep going, the idea to this was if we had a huge amount of disparity in the proportion of the data, say one of them we had 85% of the data and another we had only 50% of the data, the one that we only have 50% of the data for that column is kind of tough to work with. So that's kind of what we did, is we calculated the percent missing under a certain threshold, and we decided that this was the column to keep. So what this is saying is that if we had a column in which the percentage missing was less than 15%, we kept that column. And another way of saying this is a column that had at least 85% of its data in it, we kept it. Things that did not meet that cutoff, we ended up overwriting, because we then took this columns to keep condition, and we created a DF filtered, which was a filtered data frame using that. And then we kind of went with that. And as you can see, when we took the DF filter, it has 4 columns that we deleted. The next thing we did was we looked at the data, and we felt if there was really extreme binary data, so it says in the example here, 173,000 yeses and 23 nos, we thought that something like that would be pretty tough. For example, it's a AAA membership data set. Columns such as membership ID might be useful, or it could be every single person in the data set is basically a current AAA member. So what we did is we looked for columns with a high imbalance, so things with 95% and up. And then we did this code right here, and it was actually a function to identify those columns for deletion. And then we printed out the columns for deletion here. As you can see, these were our highly imbalanced columns. And yeah, that's basically what we deleted. So as you can see, that actually deleted 8 more columns. So the last part of the column cleaning was to see if it would make sense to change any categorical variables to missing variables. And this is important because it could help to kind of avoid problems with regression or any data or whatnot. So there's an example code sample that we did here. But the number of columns before applying the operations was 90. But we can see the number of columns after applying the operations was 90. But this makes sense because we replaced a lot of those null values with things that would cause linear regression to work. So again, null values, NA or unknown, can throw off mathematics. So what we decided to do is we decided to place in, it looks like it was replaced with the mean here. So we replaced those values with the mean, and the total number of NA values was taken care of. So going into row cleaning, we then decided, let me just make sure this notebook, let me just make sure the notebook is caught up. Yeah. Now we get into the row cleaning. We wanted to delete everyone because we wanted to delete everyone who didn't live in the state of Massachusetts. So we're only interested in Massachusetts customers. So we can see there's a conditional that we set, and then we overwrite the data frame based off of a conditional. So the number of customers that do not live in the state of Massachusetts is 5,000. So we then could see from the printout blurb in the helper function that there's about 5,000 rows that we lost from that. So row cleaning number 2 is delete all of the rows where the member flag is not equal to true. And the reason for this is, I kind of alluded to it earlier, AAA data, it's not, I mean, it is helpful to have, it's extremely helpful to know what demographics you don't have, but just the nature of AAA member data kind of implies that the data is not going to have a lot of people who aren't AAA members, or it doesn't make sense really if it would. But we had data here, and we were able to delete, it looks like, about 1,000 data entries of people who their answer to whether or not they were a AAA member was not yes. And then we wanted to delete all the rows where the membership had been canceled. So as you can see, their membership status has been canceled here, and similarly, you step through it, there's a huge disparity, but that's probably close to like 60,000 or quick math, so don't check me on it. But as you can see, the shape of everything has changed. And after we did that, we kind of just did a df describe to try to see some of the thoughts and things on the data. And basically that was it. The last thing we did was we actually we printed this to a CSV. So we printed the data frame to a CSV. So actually we have a final output CSV that we use to submit for this project alongside this code. So that's everything, and yeah, thank you.